Okay, number 8, it is asking you to determine whether the system has one solution, infinitely many solutions, or no solutions. So let's take a look and see. Okay, so I'm thinking I want to eliminate one of my variables. Looking at my x's and my y's, they're the same number, just different signs, so I can multiply either the top or the bottom by -1. I'm going to choose to multiply the top by -1. You could have chosen the bottom and you still would have gotten the same solution. So multiplying every term up top by -1 will end up making all the signs change. So I'll have -5x minus 6y equals -11. So now I can add. So now adding my x's up, I get 0. Adding up my y's, I get 0. So I'll have 0 equals -11 plus 33. -11 plus 33 is 22. So I have 0 equaling 22, which is not true. So my answer is going to be no solution. Number 9 has us again determining whether the system has one solution, infinitely many solutions, or no solution. So let's go ahead and figure it out. So we have both of our equations. Now looking at my x's and y's, I can make them both the same number by multiplying the same number, because 4 times -x gives you -4, 4 times 3 gives you 12. So it will give us the same number and allow us to eliminate because there'll be different signs. So let's multiply the top number by 4. So we have 4 times every term in the equation, which 4 times -x is -4, 4 times 3 is 12, and then -2 times 4 is 8. So that'll give me -4x plus 12y equals -8. So now I can add them together to eliminate my variables. My x's become 0 when I add them. My y's become 0 when I add them. -8 plus 8 gives me 0. So I have 0 equals 0, which is a true statement. It is true, so that means I would have infinitely many solutions. Okay, number 10 is asking you to solve the system using any method. I'm going to choose to use elimination to give us more practice on that. So we have x plus y equals 4.8 and 5x plus y equals 4. So now I notice right away that both of my y's have the same number. They're just the same sign. So what I'm going to want to do is make one of them negative. So I'm going to multiply the top by -1 to make it negative. So multiply everything in the top equation by -1, and I'll have -x minus y equals -4.8. Now I'm going to add them together. -x plus 5y is 4x. The y's cancel out, become 0. -4.8 plus 4 will give me -0.8. So now I'm going to divide both sides by 4, and x is going to equal -0.2. Now I'm going to put the -0.2 into the first equation for x to find y. So -0.2 plus y equals 4.8. Add 0.2 to both sides, and I'll have y equals 5. So my ordered pair is going to be -0.2 and 5. So let's put that in, and it does say we can use a decimal in this case, so we don't have to turn that into a fraction. -0.2 and 5. And there's number 10. Okay, so we're solving the system using elimination. Looking at both of these equations, we see the variables are inside of a fraction. That's okay, we can still use the same methods to solve it. So what we're going to want to do, same as the other ones, is make either our x's the same but different signs, or the y's the same but different signs. Me personally, I'm going to make the y's the same but different signs because they already are different signs. All I'd have to do is multiply it by +3 to make this 12 to match the 12 at the bottom. Remember, when we multiply by a whole number on a fraction, you multiply it to its numerator. So let's do that. We're going to multiply everything in the top equation by 3. So 3 and 4 over x, 3 times 4 over y, or -4 over y, and -14 times 3. So that will give us -12 over x minus 12 over y equals -42. When we add fractions and the denominators are the same, we just add numerators. So for the x's, we have 12 plus 2 is 14, so 14 over x. The y's, -12 plus 12 is 0, so the y's are gone. The 42 plus 49 is 7. So we have 14 over x equals 7. Now, to solve for x from there, cross the x out and bring it to the other side and multiply it to 7. We'll have 14 equals 7x. Divide both sides by 7 and x equals 2. Okay, now we got to substitute it back in to find y. I'm going to use my top equation, and I'm going to substitute x with 2. So then we have 4 over 2. 4 over 2 is 2. Now I can subtract both sides by 2, so then I'll have negative 4 over y equals negative 16. From there, we have a y at the bottom, so cross it out and bring it to the other side and multiply it to negative 16. We'll have negative 4 equals negative 16y. Divide both sides by negative 16, we'll have positive 1 over 4 for y. My ordered pair will then be 2 and 1 over 4. So let's put that in. And it's correct. There is number 11.